All right, now let's welcome our next speaker, Mr. Greg Fisher, founder and CEO of Berkeley Sourcing Group. He's going to present challenges that wearable startups face during the stage of manufacturing. Thank you.
Hey everybody, how you guys doing? Do I get a clicker?
Clicker? Hang on.
Who here is part of a hardware startup company making a physical product? Yeah? We have service providers here. Okay, what are you guys interested in knowing about? Yeah, you want to build the next big thing? Just here hanging out. All right, let's. Well, what I'm going to talk about is really a lot of the challenges that a startup faces when they go through the manufacturing process. Specifically, how that relates to wearables and sports products. But really, a lot of these challenges are pretty common throughout the industry, and particularly, specifically relevant to startups. Making a hardware product as a startup is really a different challenge. You have low orders. You have usually not as much cash flow. You don't have the existing relationships, the engineering team, the manufacturing experience often. So it takes a little bit of a different mindset than it does at a big company where you've really got all the different divisions designated to solving those problems. So I wear 3 hats. So I am the founder, CEO of Berkeley Sourcing Group. We've been working with startups doing design for manufacturing through the manufacturing process here in China and Silicon Valley for about 12 years now. We've worked with over 900 products in that time. So we have a pretty unique perspective on what it is to be a startup and how to get those products manufactured. A few years ago, we were running into this problem where, hey, we could do our job really well, but then, yeah, it was hard to make the sale. It's hard to raise the money. There's all of these other parts that are very difficult. And we found that really startups were not getting connected to the information, to the people that they needed to be talking to. So we created a community called Hardware Massive. We've grown from last year. In January, we had 4 chapters around the world. Now we have 27. We're growing about 15% a month now, and it's a place where you can go to live events. At many of these chapters, we have events every month. You can go hear talks like the ones you're hearing today. And then there's a lot of networking and demos and really trying to create those face-to-face real relationships at those events, and then drive the online community where we have blogs and podcasts and videos of the speakers and lots of other online resources where you can continue to learn, once you get home. We also actually have an event tomorrow night in Shenzhen that'll focus on retail. Kyle from Beta, if you guys know Beta, that's a unique retail platform where they have a store and you can actually just rent the space, and then they give you great customer feedback on how you are doing, how the customers are relating to that at a pretty fair cost, actually. That's also Silicon Valley, but you can check that out tomorrow night. And then we do an annual conference, which has an expo, a much smaller expo than here, but is more focused on the conference side of more tracks and speakers in Silicon Valley every year. That just finished up. So the strategy of manufacturing for startups in sports and wearables it needs to be a little bit different, as I mentioned. First of all, you need to have the right partners, right? It's very difficult to do all of these things that you need to do as a startup. You're going to be spending a lot of your time probably raising money, trying to make sales. So you need to pick your battles. You need to decide, hey, what are you going to invest your time in, your team's time, and really try to find the right partners to do the rest. So for manufacturing, the critical elements, it's very easy to go on and find suppliers, but how you choose those suppliers is pretty tricky, and it takes a lot of conversation and back and forth. In my mind, the things that you really should be looking for is high integrity. You can find this with references or discuss with other people that have worked with those partners. Transparent. There's a lot of little details in manufacturing that a lot of manufacturers or partners are not willing to share. So find the ones that are really willing to get in and give you the details of all the BOM costs and why they are that way. A really simple one that is often overlooked is just simply the responsiveness to your questions, right? If a partner is getting back to you very quickly, is it an hour, is it a day, is it a week? You, as a startup, you need to move fast. You need partners that are really ready to move at that pace. Experienced, and particularly with startups, there's a lot of people coming from manufacturing or coming from big business, and they probably have not themselves developed the system from scratch, right? All the workstation instructions and all those other details. So you experience with startups is really important because it is a much different game than typical manufacturing. Able to execute at the factory level, right? Being on the ground is really critical. And then also focused on the long term. There's a lot of things that you can do to set up the manufacturing process right that don't necessarily have to be done, but they will. The way you make money in the manufacturing part of your business is by not having problems, right? If there's a little bit of a cost increase, that's going to be very small relative to the cost of a defect, or certainly a whole container full of defects, or a flight trying to fight fires out to your factory and delayed and getting your customer product. So really value, the getting things set up right in the beginning, and I'll go through how we can get that done. So. An important thing is to really understand the responsibilities, right? There's different ways that you can have set up the relationship with your partners. Bigger companies, you'll have huge manufacturing contracts. If you're working directly with a smaller supplier, it may just be done on a handshake. And either way, when things go wrong, it always comes back to this, is that it's really your responsibility to explain to the factory what the expectations are of the product. And if you haven't done that clearly, then that's really on you, because they don't know the market, right? They don't know your goals. They don't know your business plan. There's not enough time for you to really explain to them all of those details. So you need to explain to them, hey, this is what it needs to do. This is how it needs to work in the market. And then they can use their experience and they can apply that to all the processing, the testing, and so forth to get the right outcome. But if you leave some details out, if you're not clear, then there's a lot of room for finger pointing and issues that come up later on. So really have to understand and communicate that to them. And this is specifications and tolerances, right? Specifications without tolerances are really not very useful. So shift gears here a little bit. This is one of our early products called the Clean Bottle. Anybody making a sports product here? I know Wearables is the hot thing. All right. So sports is more traditional manufacturing. Usually this is blow molding, injection molding, also fabrics. With any manufactured product, it's going to come down to the materials and the processes. So that's where it all starts, and then you get the machines and the specifications and how that goes through. But sports industries, usually typical traditional processes. Simple things, the thing to learn out of this is simple things can be very difficult. So this is a regular sports bottle, but it opens on both ends. Well, in this case, the machine is set to spin trim the opening from registering at one side. So when we were making this bottle, there was no machine that was set up to cut both sides of the hole, right? And if you're looking at this, without understanding how that works, it's very difficult. You think, wow, it's a simple bottle, right? You just pop it out and here's a design and we're done. But if there's no machine set up to do this, it becomes really an engineering challenge. And I make this as a very obvious example, but this happens all the time in our experiences, that there's an undervaluation of some of the difficulties that may seem very simple to do, And when you run across those, discuss those with your manufacturer, understand the process behind them. You may have to give a little bit as far as what the product can do or the price in order to get it right. But instead of being a bit bullish and just saying, hey, get it done, you really need to add to that conversation and find a good point in the middle. A couple other things that were really interesting here. If you're a startup, you have to compete on innovation and do things a bit differently. The big companies are going to win the price game. They're going to win the distribution game. So you have to differentiate in another way, right? Dave came from a marketing background, the founder here. And when he first made this product, he made a clean bottle human costume. And he went to the Tour de France. And every day he would get up, he'd hike up the mountain, and he'd put on his clean bottle costume, and he would run down while the cyclists were cycling by him. And now you imagine the Tour de France, I think it's 23 days, something like that, and a bunch of cyclists that gets international airtime, and everybody in the cycling industry, obviously really interested in that. And these announcers, what are they going to talk about? Watching a bunch of guys cycle, on a hill for a while. After 10, 15 days, Dave is coming out in his clean bottle costume every day. Wow, hey, there's Dave, the clean bottle guy. And all of a sudden, they're talking about him for 5 minutes, every time people are watching the Tour de France. So guerrilla marketing, think about it. What is a way that you can touch your customer in a unique way that the big companies are not? Oh, he had Bill Walton, who I don't know if you guys are into the NBA, but he's one of probably the top 15 best basketball players in history, at least top 30 for sure. He's also 7 feet tall. I don't know about that tall. And so he made a clean bottle costume for Bill Walton, and Bill Walton jumped out of a clean bottle costume on the Shark Tank episode and made them the #1 Shark Tank episode that I think still to date. But it's that kind of unique approach that really can help get the sales and compete. So back to the manufacturing. So the communication is another thing that is really undervalued. There's a huge difference from our perspective in working with a customer that can communicate well and ones that don't. And it makes a big difference on your ability to get to the finish line and be cost effective and not have any mistakes. Make an effort, right, from your side. Don't just assume that it's easy. Be clear and concise. Whenever you're there's a lot of information in manufacturing if you're doing it right. So you really want to make it as clean and simple as you can. Take out all the fluff and stick to the details. Instead of writing 20 emails in a day that describe different things, really try to keep it to one and be organized, put it all together in one time. This is going to go through many different hands, right? From you as the startup founder to the worker on the factory floor, there may be 7, 8, 9 people that this is going to get translated through. So if people are trying to cull out all the information from these 10 different emails and get that through the chain, it's much easier for something to get lost than if you put it in an organized document. The other thing is while conversation on the phone is really important and great for developing relationships and a closer connection, anytime you do have a conversation on the phone or video call, you really want to follow that up with something written. Anything in writing, people throughout the supply chain can refer to. They can refer to it that night. They can refer to it in 2 months. There's a good record of having that conversation. So don't just assume that because you told somebody something that it will get done. Try to follow up and make it all in an organized fashion. Finally, and this is a tough one, but a really important one, is try to be quantitative. Right? If you say, hey, I want a red shirt, and you need to make it perfectly, wow, there's about 1,000 variables that are missing from that statement, right? There's red there's 1,000 kinds of red, right? So if you want to describe what kind of red you want, you can use a Pantone number. Right. If you're looking at a surface finish, there's quantitative ways for saying what kind of surface finish you want. Rough or smooth, matte or glossy is maybe not going to be what you really want. So get into the details, learn that language, and be able to describe that. And if you're not sure, hey, I want red, but you're not sure exactly which kind of red, your partner will know. They'll be able to point you to the right resources to be able to communicate that. So just make sure that you're focused on that. One thing that is often really missed as a startup and putting things together is the testing. All right. When you have your specs, you go to manufacture your product. That's one process. When the product comes out, how it gets tested is a whole nother process. It takes different tools and equipment, different definitions and guidelines, and it's a translation of those specifications into the process of testing that I think probably gets the least amount of focus and is one of the biggest things that could be improved on for startups getting into this. You're so focused, at that point you're working with customers to get sales done, you're finishing up manufacturing, you're troubleshooting some of the things in that process, and nobody's really focused on what is an acceptable product and how do we confirm that it is acceptable. In manufacturing, this is another important thing. There is no perfect. Perfection costs infinite dollars. So unless you happen to have infinite dollars, you will never get perfection. So you need to understand what is the level of imperfection that you can accept. And all consumer products have, a tolerance. There's nothing that is exactly 5.00000 whatever centimeters. It's plus or minus a little bit. And so you need to understand what is the level that you can accept, what is the level your customers can accept. The stricter you are, the more it will cost, the harder it will be, the more defects there will be. And so you want to really understand your customer, your market, and pick that tolerance level that works best for your process in your market. And then you work with your factory, your partners, to build that into the inspection criteria. So just real quick, there's a few different forms of quality control. There's, if you're looking at inspecting the product, you're going to have raw materials coming in, you're going to have incoming components, you're going to have the in-process quality control, and the outgoing quality control. Again, you probably don't want to learn all the details about raw materials and incoming and in-process. There's a lot that goes on there that, as a startup, would be overwhelming just to even learn the science behind that. So you're going to probably need to rely on your factories, make sure that you're working with the right partners to do that, and then focus mostly on the outgoing control, right? What is it supposed to look like when it's all put together, when it's all done? And a lot of that needs to be done in process and so forth, but at least the key is that you can catch it before it gets on the boat. Right? If you have any consistent defect that gets on the container, the least of your worries is the defect at that point, or even the cost of replacing that product, because at that point you have all the commitments that you've made that you're always just keeping enough inventory to supply your customers, right? That it gets on the boat and you find the problem, hopefully, when it lands, in worst case, when it gets in your customer's hands, and now you have no product. You have to recall all that. You have to start the manufacturing process again. You have to pay extra to really get that done quickly often. You have to airship things, and you have to do a lot of damage control with your customers. And usually, very few startups survive that situation. So it is totally worth it to have a third party or yourself do that quality inspection before it gets on the boat, and make sure everything is right at that point. Factories are good at manufacturing. They're not good at marketing. They're not good at understanding customers. They don't often understand your customers' expectations. You've done a lot of research to figure that out to sell those products. Help your factory out by helping them understand what that product is supposed to do in the market. If you're with the right partner, if you're explaining that at the high level, the boss and the engineers should be able to communicate that and translate that into something that can be effective throughout the manufacturing process. Final thing about testing is that it has limitations. That just because you've built a good routine doesn't mean that it will be perfect. And just as the manufacturing machines have limitations, the tools used for testing have limitations. So you'll want to understand what those limitations are. A big one is that you want to know that and understand that that testing is only valid where it was tested and by those tools. You know, we had a really interesting problem with a lighting product at my previous company where we made, I think, 20,000 automotive lights, and they were tested. We had a great partner. They were tested well at the factory in around Shanghai. They got to Las Vegas, and we did a drop test, and it dropped and it just shattered, exploded. And we were like, holy moly, you know, what's going on here? And so after a little bit of research, it was the dryness in the air of Las Vegas and the heat that sucked all the water out of the plastic, made it very brittle. And the drop test that it passed in near Shanghai, it no longer passed in the environment of Las Vegas. So environmental concerns, durability, and safety are some of these things that can be affected by the use case scenario when it's out in the field versus when it's at the factory. And those are really the items where there are those differences, that you don't have the controlled factory environment, that a lot of the biggest issues come out. You know, look at the Samsung phones, right? They probably did well in the lab, and then they get out and they're in different environments, and a lot of problems happen. So think about what are the use cases, what is the environment that your product will be used in, and really try to focus on those beyond the normal testing, because that's where you can really save some hard times. Of course, always be very, very in tune with safety. So here's a wearables product we did. This was really one of the first wearables that came out, I think about 3.5, 4 years ago. And this is drum pants. This is music in your pants. So very fun product. Key thing about wearables, especially in this use case kind of scenario, is that electronics and soft goods have not historically been put together very much at all. If you look at most of the electronics factories here in Guangdong, it's some SMT and some PCBA, and you put together the electronics, and then you put it in a plastic box or a metal box, and you ship it out, and that has been all very tested, and you know there's decades of history of us working out those kinds of problems. This is something you put in your clothes, right? It's flexible. It's going to get wet sometimes. It's being pounded on. And so this has not really been done very well, or there's not been much history with this. And so in that kind of situation, you really need to add a lot of help to the factory. You need to think of those use cases. Make sure, you know, in this case, we did a lot of redesign on the internals and a lot of testing before we were comfortable to ship out the product. You know, we played around with the solder joints, flexible PCBs, did a lot of work with the sewing patterns and how making sure everything was there was not a lot of movement on the internal there, and just really rigorously went through that, because this exact same problem. We knew that even though maybe we could make it look good in the factory and get out of the factory passing the tests, it was going to experience a whole different life, you know, once it got out into people's clothing and their expectations. So definitely want to pay a lot more attention when you're working with these products. And this is also another challenge in that the electronics factories don't have the in-house sewing capabilities typically. Those are two very different worlds in the spectrum of manufacturing, soft goods and electronics. Electronics is very consistent. Once you get it right, all of those electronics come off the line very consistently. There's very little variation. Soft goods are totally the opposite. Everyone is almost its own unique thing. They're often somewhat handmade, even though there are kind of automatic sewing machines and so forth. There's a lot of variation in every fabric product. So how do you control that? You really want to make sure those factories are working well together. What we offer is experience with both, so we can kind of see what those tolerances are, understand the process, and get those to work together. But you will probably want to work with somebody that does have that understanding of both of those very different kinds of processes to meet them together, or you're going to be stuck where the fabric factory is saying, well, I provided a good product to the electronics factory. They didn't assemble it right, and a lot of finger pointing that gets very difficult. So the execution. So if you've done the rest of your job well, setting it up, the execution part hopefully will be the easy part. There's always troubleshooting. There's always things to work out, but the harder part is really getting it set up right. How you get it set up is through giving that very clear detail of what you want to make, being connected on the ground, and then understanding the process as you're troubleshooting. So take a quick side view again of the sweat gutter, and this was really an execution challenge as a product. So this is it's a silicone band that goes around your forehead that gutters the sweat away from your face. So again, cycling, tennis, active sports. This client came to us. He was already in production, but his defect rates were about 50%. His cycle time was about 1 hour to make one product of these. It was really, really painful. And we were able to kind of work with him to really get into every detail, right? There were bubbles in the product, there were impurities in the product, and so it's really a matter of looking at the whole process, really understanding that, making it clean, using different processes, and working with him really to understand what it was that he needed to do. The result was that we cut the cycle time down by 50%. The defect rate went from 50 to 10%. So these kinds of metrics are achievable with the right focus and the right team. This is what I feel like, and I think all manufacturers feel like we get a lot, especially from startups, is I want this beautiful picture. Here it is. And this is the information we get. And we're like, oh, man, how do we do that? And this is really what they want, right? This is the end product that they're looking for. And this is what we're working with. And we don't really know, how to get to hear what these flowers are going to look like if we're given that kind of information. So remember this. If you take one thing away from today, remember this picture and what this means, How do you do that? How do you paint that picture, right, for manufacturing? I'm going to run through these fairly quickly because this is all on the web and it's not the most exciting thing in the world to talk about. And this is where you just have to do your homework and kind of figure this out. But these are the key documents that you'll want to focus on when you're going to manufacturing. Product requirements document as a startup, probably the single most important thing that you can do. This is the document that really describes those marketing expectations. It describes how it's supposed to look, how durable is it supposed to be? Are there safety requirements? Are there certifications that you need to meet? What does the user interface look like? What's your target demographic? Right? What are all of these intangibles of what you're looking for from the market expectation? And the reason this is so important is because it's very difficult to know all of the exact details that the manufacturer would ideally like you to communicate in that quantitative way. So, hey, if you can do a good job of explaining what the market needs, what the market expects, then the manufacturer can do a lot of the work from there. Bill of materials. So if you're doing a wearables product, you'll have an electronic bill of materials and a mechanical bill of materials. Keep those separate. There's a lot of value in each of those. One thing is that as you're getting quotes, a bill of materials will keep you honest and make sure that you know all of the parts of the product that need to be made, and that make sure that those are communicated to your factory to get those made. You can keep it pretty simple. I definitely suggest part name, material, and quantity of the components. And then if there are more questions, the factory can come back with other questions. The important thing with the electronics bill of materials is if you have the part number, then you don't need to send all of the specs associated with those parts, right? Those electronic components, there's a lot of details in that part. And if you can just give the component number, your partner can look that up. They can have all of the tolerances, all of the specifications right at their fingertips. So try to be as detailed as you can with those part numbers, and include that in the bill of materials. The other thing that this does is if you can provide a good bill of materials, some of the early stage things like what is the lead time going to be can be examined and reviewed. Some electronics components have 8, 10, 12, 16-week lead times depending on what you're trying to do. And that can push back everything if you're not prepared. But if you can send a bill of materials a little bit earlier on as you're finishing that design, then your partner can start to look at that and maybe order those really long lead time components right away. That can save you maybe a month or more in that lead time. Technical files. So these are the documents that really show exactly what the product is going to be. Fundamentally, 2D files, 3D files, and Gerber files. Was what most people are working with: injection molding, metals, rubbers, you name it. They can mostly be defined with those. Soft goods are a bit different. Actually, prototypes can be more effective there, but 2D files are something that are pretty underrated. Everyone thinks, oh, I gave the 3D file, and that entails that has all of the information. Why do I need to send a 2D file? Well, there are some things that you can really clearly communicate better in a 2D file than a 3D file, and these are tolerances of certain areas. There will usually be some critical dimensions that you want them to be maybe as small. If it's a plastic part, you want it to use as little material as possible, but you also need to make sure that it is structurally safe, that it won't break. And so a 2D file can show that exact cutout of the plane there, and you can say, hey, I need this part here to be exactly this dimension. And that's a good way of really ensuring that you'll hit what you need at the best possible price. You can also add more information like surface finish on 2D files and other things. So where there are some critical features, 2D files are really useful to make that very clear. Hey, this section is where all of this information needs to be. With 3D files, beyond just being able to do the injection molding and the other parts of critical to manufacturing, there's a few things you can, if you have the 3D file, you can easily calculate the amount of material. Right, this allows you to give a really quick turnaround on quotes, and then in any case, you'll need to look at what does that tooling look like, right? Mostly how does the tool open is really the critical feature in injection molding, and that'll define a lot in the complexity of the tool. So prototype. So truly, if a picture is worth 1,000 words, I don't know how many words a prototype is worth. It's a whole lot more than that. And as much as you can define a complete product with all of the other documents that were previous to this, the prototype is something that your partner can touch and use and experience and can sometimes immediately see issues or better understand the use case in real life to get to what the real product needs to be. And just like, I don't know how many of you guys have experience with marketing, but if you make an ad on a computer screen, when you go print it out, it just looks different. Something looks bigger or smaller than you expected, and it doesn't usually quite look right. So after you print it out, usually you make some changes. Manufacturing is just 1,000 times more complex than that. So you can imagine all of the things that didn't quite look or seem the way they seemed on the screen and in the file. And so having that prototype is really valuable. At the same time, usually as a startup, you won't have a prototype that is well done. It's probably not designed for manufacturing. You're probably already, as soon as it was completed, you already had 10 changes that you wanted to make, prove it. And so the best way to use your prototype is to say, hey, here's my prototype, here's the basic idea, but these are the things that I specifically have to change, and these are the things I would like to change, and this is what we're working on. And so really clearly communicate that, hey, this is what we've got, this is where we need to be. And if you can do that part, including that communication in that prototype, then prototypes can really be effective. So we often get a question about lead time and everything. There's usually an underestimation of how long it takes. Real quick, this is what a typical manufacturing process looks like. So you get that completed engineering package, right? All those documents that I went through. And then before you go to production, you'll want to make a pre-production prototype. So this is after you apply the design for manufacturing to that completed engineering package, and you really get that design ready for manufacturing. You want to, spend that $1,000 or $2,000 or whatever small amount of money that is to make sure you've really got the product as dialed in and tested as possible before you spend that $30,000 or $40,000 on the tool. So, maybe it's 20, 30 days for that. If most of our clients are in the US, so, we're shipping this and they're testing it, so maybe about 14 days for approval. Tooling between 30 and 40 days from, when the partner receives the funds. So there's some more time there and some modification in that. If you don't have any long lead time components, and if you've got all the components ready by the time the tools are complete, first production is maybe 30 days if things go nearly perfectly. Definitely can be a lot longer than that. Troubleshooting and QC, another maybe 2 weeks. If you're shipping ocean shipping to your market, another 30 days, and then maybe 7 days to receive those goods and to ship them out again to your customers. So it almost never goes as fast, right? Sometimes it does. If you have kind of a simple electronics product in a box, this can definitely be done. If you're doing a wearable, there's going to be a lot of use case testing and understanding that is going to add quite a bit of time to these processes. So when you're doing your crowdfunding campaign, when you're talking to investors, the more that you have insights here and that you can communicate and understand each of these processes, the more professional you're going to look, the happier people are going to be. And two, the more you can plan ahead for the kind of testing that goes on here. And again, the most important work was before day zero. It's really, if you can provide a really good engineering package, this stuff can all go very smoothly. In my experience, it's not usually the manufacturer that delays things so much. I mean, there's good and bad partners, certainly, but where that really becomes apparent is if the engineering package is not well done, that a bad factory will really struggle with that, and they won't, and they'll come back and say, oh, all these things weren't defined, so that's going to cost you twice as much, or that always adds into the price. So that adds to this time quite a bit, right? You imagine what you're trying to work with. If your pricing doubles, you may need to switch factories and have all kinds of other course corrections. So definitely get this question a lot with IP and manufacturing. Obviously, a lot in the news about products being copied right now. The I'll knock on wood, we've never had a supplier in our network copy a product to our knowledge and compete in our markets, US, Europe, et cetera. And part of the reason is because, well, partly we work with more Chinese manufacturers who don't speak English very well, but factories are not really good marketers typically. It's not usually the factory that you're going to be competing with for your product in that market. It's the people that have the access to that market, and they may be somehow connected to the factory and so forth. But first you need to realize it's very difficult to market a product, right? You need to have a complete business plan around your IP and how you're getting to market. And you're going to have to educate your customer. You're going to have to find those sales channels. So I'm not at all saying that you shouldn't be concerned. You absolutely should, and you should be careful. But at the same time, it's going to be very difficult to do the manufacturing itself. That's the other, sales and manufacturing are the two hardest parts of what you need to do. So if you're going to go in, you really need to be ready to go in with the right partner and give them all the information and really support them to do what needs to get done. So of course, definitely try to choose the right partner. And those that either have less ability to market the product or you can really verify their integrity. They've worked with a lot of startups and they have a lot of references that can vouch for them is really important. China trademark, this is really easy now and at least really protects your tool. You know, if you make an injection mold for $20,000 and you have your logo in it, then it's going to be a decent amount of work for them to make another tool without your logo in it. And that's about, I think, $300, something like that now to get that China trademark done. At the same time, if you wait until your competitor gets that product to the port and they catch them at the port and destroy all those goods, you've probably put them out of business because they just spent a whole bunch of money making all that product. They have those customers waiting for those products. They have that tooling that they now can no longer use. So definitely a really cheap way, and something you should always get if you're producing here is a trademark. The government's done a pretty good job enforcing that, if you can be aware that people are selling that. The other thing that we can kind of offer and others can offer is this leverage of partner deal flow. Is that when we're working with a factory, we're sending them multiple products. We're sending them, a continuous stream of revenue, and so they don't really want to risk their business with us on the potential of selling a one-off product that is not their product, that's not, could really hurt their reputation, and so forth. So there's this idea that if you have a good partner with a good partner network, there's a lot of added value and incentive for your product not to be ripped off. Finally, though, this is a total business strategy. While we haven't had our Chinese suppliers steal and knock off our products, we've had American companies, we've had Taiwanese factories, we've had lots of other people in the market that did. And so you need to be careful. It's really, you need a strategy, right? How are you going to create the brand? How are you going to create the cash flow? How are you going to partner with the right people to protect that idea? It's not just about patents. Patents are good to keep people away and maybe build a relationship, but if there's a large company that takes your product and starts selling it, you probably have very little ability to take them to court. Just the legal fees would put you out of business, right? So I think we have some time for questions.
Any questions from the floor?
So we have, as I mentioned, we have this checklist that you can download. This gives a lot more information on those documents that I was talking about earlier, bill of materials, product requirements document, and so forth, and gives a deeper dive into the strategy. So definitely suggest checking that out. That's probably the most common question we get.
So any questions? No? All right, thank you very much.
Hope to see you guys tomorrow night.
Thank you.